Alright. How you going, boys and girls? I did it again. Tried streaming without the audio working. Last time I did this, I had a USB microphone plugged in. This time I don't. That shows how long it is since I've done a video. Anyway, start again. So I haven't done a video in a while. Just haven't felt like it, and been too busy to get the gear out. And the main reason is I couldn't find my laptop charger. Anyway, I found it. So here we are. So we've got a Blackstar. It's a HT Club 50 Mark II. However, the boards say HT Venue Club. So I don't know if it's a last minute name change or what. You guys let me know if it sounds good, alright? Yeah? Fucking hell. Yeah, so we'll go over these things. And I'll show you the issues it's having. So Blackstar, some guys refuse to work on them altogether because Blackstar are pretty tight-lipped about their schematics. Being surface mount, a lot of guys get scared off and want to rely on schematics instead of actually tracing the circuit out like they're happy to do in a point-to-point or, you know, hand-wired amp. It's really no different. It's just smaller, so if anything, you don't have to trace stuff as far. So to me, it's easier. It gets tricky when the boards are double-sided, which this one is. But if you know what pin does what on a tube, you can pretty much figure out anything. You can reverse engineer anything. It just gets tricky when they've got proprietary things like this board, which is basically a computer. That's got some control circuitry on it and the digital reverb, because there's a digital reverb in this. There's no reverb tank. So it's got two valves, one for the clean channel, one for the overdrive. Not sure if they cascade into each other for the overdrive. They may do. We'll suss that out when I tap on them, eh? It's got a solid state phase inverter with two FETs there. I believe they're FETs, IRF 830As. And that feeds into the two EL34 output valves. So, a few things with these amps. For some reason, it's got a standby switch. For some reason, the standby, instead of cutting off the HT, the high voltage, it actually takes the bias way negative, the bias voltage way negative to the control grid. So that puts the valves in cutoff and has the same effect. It shuts off the output stage, so nothing goes to the speaker. Don't ask me why they did that. It's much easier in my mind to just turn off the HT, but don't know. So a lot of guys will poke around in these things, taking measurements or whatever, and they'll scare the shit out of themselves because they'll think that the HT's cut off when it's not, and they'll shock themselves or short something out. So they put voltages of 380 volts AC and 550 volts DC are present within this unit, but it doesn't say at all times. However, there's a sticker on the other side that says high voltage present at all times in this amplifier. Well, when it's switched on anyway. So, yeah, that's one thing to be aware of with these. So this one came in with reports of noise, low headroom, distortion happening at pretty low volumes, and these faults happening intermittently. When the customer was here, we plugged it in, tried it out, because there didn't appear to be anything. There wasn't blowing fuses or anything dramatic, so we thought we'll see if we can simulate the fault, just so we're both on the same page on what's wrong with the amp, which I like to do if it's not a catastrophic fault. Usually I'll take it open, make sure there's no physical damage in there or anything. I mean, what's turning it on one more time, and it's been probably turned on 20 times to try and hope the fault doesn't appear. So I fired it up, sounded okay, pretty good headroom, didn't really notice anything wrong with it. So I told him I'll chuck it on the bench, put it under test for a while with some signal running into a load, and we'll just monitor it over a while. And I plugged it back in after he left, and I didn't have any input plugged in. So I noticed it was really noisy. And that's not normally the case in these, because they've got a mute circuit attached to some shorting plugs, shorting jacks on the front that mutes, I think, later in the preamp, just before the output stage. It may even cut off the bias. I can't remember on this particular model. I think the Club 40 does that. When you unplug, it takes the bias way negative, just like flicking off the standby switch does, and puts the whole output stage into cutoff, so no signal's amplified. This didn't do that. It was really noisy. So that was my first sign something was wrong. So anyway, I plugged signal back into it. I just plugged a cable into it, so it was quiet. Turned off the oscillator, and then cranked the volume up to see if there was anything microphonic. And both the preamp valves were microphonic to tap on, and there was a bit of noise coming from the high gain one as well, just background, like popcorny noise. So that's usually an indication of a valve or a plate resistor on the way out. So anyway, I'll fire it up, show you what's going on, wake the meters up, put them on DC milliamps. So that's breaking the anode connection to each output valve to see how much plate current there is, and that's showing the plate to cathode voltage on the poor little dying Fluke 11 down there that I've had since I was about 11. So I'll put it on standby, I'll fire it up. We've got a speaker plugged in there so I can show you the noises. Got our signal plugged into the front. I've got the oscillator currently off. So let's fire it up. You'll notice the voltage there going up to, it says 510, the display's buggered. But yeah, that's 510 volts already, even though it's still in standby on the output stage. So then if we just crank the volume down in case it does something wacky, turn on standby, you can see they must have massive bias caps in these. It takes a while to get up to current. So that's showing settles at about 25, 26 milliamps. Reasonably balanced on the two output valves, so that's not too bad. That's about at 495, that's about 50 something percent output dissipation. So it's not bad. Higher gain, like heavier style music amps can sound better with slightly lower output bias or output dissipation, but it's a taste thing. So anyway, we're not running away there. It doesn't look like it, so we're pretty safe. Safe to poke around for a bit anyway. All right, so what I'll do is crank up the master all the way. You can already hear that. I don't know if you can make it out there, but you can hear a bit of crackling happening. So the other thing I noticed was, so the input jack's a bit intermittent. You can hear that hum just went up. Yeah, so I think we'll need a new input jack on that for that reason, and for the reason I'll show you. So hear that. Now the jack is acting like a microphone, because that's a really open line, high impedance. That cap there is now microphonic, and that's coming out the speaker. That's me just tapping around in that area. Now if I go, that's the shorting terminal. If I just go push it down, now it shorts out like it should when nothing's plugged in, and there's no signal except for the shot noise or whatever coming from the preamp valves. And if I do the same on the ground one, I've got a feeling the ground one, when it shorts, takes the output stage into cutoff. So what do we got there? yeah, so see the output valve plate current there has gone down to less than a milliamp, sorry. As soon as I let go, it goes back up. So shorting the ground terminal, like it should when nothing's plugged in, mutes the output stage by putting it into cutoff, and then shorting the tip doesn't do anything to the output stage, but it mutes the input, so we can still hear background noise there. Kind of hard to make out on the mic. It's not that dramatic, but I've also got a tiny little speaker under the bench, so it's not as loud as it would be through his 2x12 he's got. Alright, so we'll plug the signal back in, just so I don't have to hold it there. Now, the tubes, I'm just going to give them a quick tap, show you down here. You hear that? I like to turn the reverb up a little bit when I'm tapping around too, because it makes obvious what the acoustic tapping noise from just hearing it through the friggin' air, and what's actually going through the amp, because the reverb will tail off any signals that carry through the amp, so it'll make it more obvious, so you'll really know if there's something going on. Not so critical, because it's not like you're tapping on your amp when you're playing it, but if it's sitting on a cabinet, it's constantly getting vibrated by your guitar signal and can cause problems there. Anyway, we'll go back down here. So you can hear that carrying through the reverb. Really kind of crappy sounding reverb actually. Ooh. So that is the V1. So let's try V2. So that's not currently in the audio stream, but if that's arcing, that's going to affect HT going to the first valve as well, so you will still hear it through the first valve. So anyway, we'll switch channels here. So now we're on the overdrive channel. Now you can hear that second valve there. So that's not just a pop, that gives a crackle and a like pop after you've tapped it, so that indicates something inside the valves on the way out. They're rubies. Well, no, we've got a TAD and a ruby, 12AX7s. I found that 12AX7s seem to be dying really early all of a sudden. I don't know if it's the quality's going downhill, or I don't think they're not used as cathode followers in this amp, so they're not under a huge amount of stress, and the plate voltage is only what, 220, 162, 220, 215. What's the cathode there? 12. 0.6. 12. Yeah. So I'm going to try changing them out. I'll put it into off skis. I'll just pop in a JJ's in there and a grand spanker. See if that's any better. As for the jack, we're going to have to take off all the knobs off the front, undo the pots, take out all the connections and pull the board out to do it properly. And it's lead-free solder too, so well, it doesn't really mean much, just means we've got to clean it off properly. Yeah, there's the old one. Ugh. fucking greasy crap all over it. Lubed. In a rag. I reckon someone's had a kick of the cat on that already and tried spraying some contact cleaner or something inside that socket. Now, when I moved it around the valve, it didn't make any weird noises, so that's my first test to see if it's microphonics inside the valve itself or the socket being dirty. Generally, if the socket's dirty, you can sort of massage it around and it'll make weird noises. I tried that and I couldn't get it to make any noise until I actually tapped it, so that indicated to me that the contacts are pretty good and that the problem's internal to the tube. Oh, I love doing this upside down. Alright, we'll just try the clean channel first. See if that's sussed it. There's my chopstick. Alright. Now we've still got noise there. Damn. No, forget that noise. Actually, that's something you international guys probably don't know. Can you hear that weird hum? It's got a modulation, it's not just 50 Hertz. It's got a sine wave superimposed over it. And there it cuts out. That's called, what is it? Zellweger tones? Zellweger? Like the actress? It's a 1050 Hertz sine wave, I believe, superimposed over the 50 Hertz. There it goes again. And that's a signal that goes to a little box in our, in our fuse box, in our switch breaker box, whatever you want to call it. And there's a receiver in there. It receives that tone and then waits an arbitrary time, literally a random time. Its job as a circuit is to come up with a different delay between, I don't know, a minute and 10 minutes every time it hears that tone. It receives them and then starts a timer, and then after that clicks on a relay. And the job of that is to turn on and off our off-peak water heaters, so they don't all flick on at once and overload the pole transformers. It's a pretty cool system, but apparently, I thought it would be worldwide, but apparently Australia and New Zealand are the only countries that do that. Didn't know that internationally off-peak water just isn't a thing. Anyway, enough of that tangent. That's just what that weird tone is. Alright, so we've still got microphonics, but we don't have that crackling, popping afterwards. Now, I've got the gain up all the way, so you're going to have some kind of microphonics if you tap the tube. But we don't have that happening after the fact, so that leads me to think that that valve's on its way out. However, if I turn the input volume down, kind of hard to make out, but I can hear crackling in the background. Just constant, but not just hiss, but crackling. So that's usually one of the plate resistors on the way out. I think I'm hearing something there too. Maybe I'm dreaming. Every time I've heard that noise in the past though, that has been a plate resistor. So I reckon I'll change them out with some metal film ones, higher quality, and hopefully that sorts that out. So let's just try the other valve now. I'll just switch that off. You can pull the valves out while it's running, but I just don't like hearing it. could just, yeah, that's got the same greasy crap on it. Pop another JJ's in there. Try that out. Alright, still got noise. Let's try the microphonics on the gain channel though. Okay, that's not even popping now, it's good. Jesus, this thing's got some gain. Stupid amounts of gain. Yeah, that sorted that out, but we're still getting the noise with the volume all the way down, but the master volume up all the way, but only on the clean channel. So I think one of these plate resistors on V1 is the culprit. Goes away when you flick over to the gain channel, and even with the gain up pretty far, that noise is absent. So it's a clean channel only thing. So I'll change out R11 and R12. Couldn't be asked figuring out which one's doing it when they're a 40-cent part. I'll just change them both. But I'll show you. No, I won't. Bugger it. I'll just get to work. So go back to you Thursday. And yeah, thanks for watching, y'all.